Welcome to the Digi ConnectCore Smart IOmux session. We will show how to use Digi's ConnectCore Smart IOmux development tool to accelerate the development of a Digi ConnectCore system on module based design. First, let's download the tool from the Digi website. Just go to www.digi.com, find the search icon and enter Smart IOmux. This brings up a number of links. Mainly they go to the Digi documentation portal. Just select one and find the Digi ConnectCore Smart IOmux entry in the left side menu. Click on this, make sure you're on the latest version to get the latest download link, and click here to start downloading the tool. I have already downloaded this and I'm gonna start the installer next. This brings up the usual installation dialogues. Find an install location. It asks me to overwrite some things because I had a previous installation. And then the installation starts. Now I can view the README file, maybe not for now, and launch. First, I get presented with the changelog, notifying me about all the updates and recent additions, changes, and the tool comes up. So let's start a new design. Click New, enter your design name, find a design location, and you get to choose the SOM you want to base your design on. There's the CC6UL, the ConnectCore 8M Nano, and the 8X. Let's select ConnectCore 6UL for now, and I get to choose the variant I want to base my design on. There's the Wi-Fi Bluetooth variant and a non-Wi-Fi variant and a higher memory variant. So I'd recommend to use the Wi-Fi variant whenever possible, because that keeps the flexibility to update your product in the future with Wi-Fi and Bluetooth. If you select a non-Wi-Fi, you get the additional interface, SDIO in this case, going to the Wi-Fi chip on the SOM, available on the outside so you can connect peripherals. But again, I recommend using the Wi-Fi for your design so you keep the flexibility to update your product in the future with Wi-Fi and Bluetooth. The Digi SMT Plus form factor offers two methods to solder the SOM onto the carrier board. Either through the LGA pads, which gives you a very high pin count, enabling you to use all i.MX processor interfaces in your design, or with the castellated edge pads located at the edge of the SOM only. This provides a small amount of pins supporting a subset of the interfaces only. Usually there's only one Ethernet port rather than two, and a few other constraints. The castellated mounting makes a very simple carrier board design easy to manufacture and inspect, and is a very attractive approach for designs requiring a smaller set of interfaces. For this example, we go with the LGA pad layout. I can either start from an empty design and I add my interfaces as required to the design, or I can start from an existing template, for example, to ConnectCore 6UL SPC Pro reference board. Let me select the template and finish. The design opens and I can see all the configured interfaces in my design. I can see there's 10 out of 245 free pads available to add additional interfaces. So let's start modifying the design. On the left, I see all the interfaces which are mapped to the SOM pinout currently. Let's assume I don't need an LCD interface, so I can remove this, and also the PWM for controlling the backlight. So let's remove the PWM and then the LCD interface. Let's remove a few of the GPIOs going to the reference board expansion header. And I see the free pads number gets higher, 37 out of 245 right now. So now I can start adding things into my design. For example, if I would like to add an additional I2C port, I go to add new component and I see the available components. For example, 3 remaining I2C buses to be mapped for my carrier board. So selecting I2C, click Finish, brings up a dialog for additional configuration of the I2C interface. Here I get presented with information that I need to define the SCL and SDA lines in my design, and brings up that snippet of the device tree pointing me to the location where I would have to make those modifications to assign the right GPIOs to provide SCL and SDA lines. Further, I get a section for the actual I2C peripherals, and the tool tells me that I need to configure that afterwards to support my I2C peripheral. So I click OK, and I find my new interface on the left here in the mix. Let's just add another thing here. For example, an additional UART port. The tool tells me I have 5 remaining UARTs. 4 of them come from the IOmux processor, and we have one additional one, the 5th one, coming from the Digi microcontroller assist. An additional microcontroller Digi is providing on all SOM designs to provide additional functionality and additional peripherals, for example, that UART here. So I can add a new UART from the IOmux processor, and I select the number of lines, and I can finish, and I find my UART in the design on the left here. Another nice feature is the device tree snippets, device tree help. The device tree is the configuration file for the Linux kernel representing your exact design with all the interfaces and electrical pad configurations. So for every interface in my design, I can pull up the device tree hint, providing the definition in the device tree for that interface. For example, Ethernet, I see here I have my FEC1 and then the IOmux configuration for the pads providing Ethernet 1. Or for the UART, the one we have just added, I get the device tree. This is UART number 4. It enables the UART and the configuration, and I have the IOmux pad settings down here in that section. Let me show a few more things on how you can work with the interfaces. My I2C interface, for example, I see this is assigned to pad A10 and A18 now. If I want, I can lock the configuration, so the tool is not modifying these when you add additional interfaces or remove interfaces, and the tool automatically rearranges things to find a working configuration. I can also switch that to other pads where that function is available if I prefer to have it on a different pad. I can also select the individual pads and then change the electrical values of that pad. I see that hex number in here, that's the current configuration, and I can go and edit these values. You can hover over the different fields and you get an explanation on what they actually mean. For example, the drive strength field lets you adjust the drive strength, tells you the different options you have here for configuring it, and then you can change things by just clicking on the individual fields, and it changes the total value to configure that complete pad. Quite convenient, so you don't have to review the hardware reference manual of the IOmux processor and find all those different options and hex values for the pad configuration and manually add that into your device tree. It's all done in a nice graphical way here with explanations embedded on the different options here. And last, you have a complete table view of your design, which you can export and provide to the hardware engineer to draw the actual schematics based on that configuration. And you can go back, get the device tree snippets, so you have your Linux kernel configuration right out of this tool as well. This can be exported, export design or export device tree, save it on your local disk and provide to the other design engineers. So in summary, Digi Smart IOmux provides an easy way to create a design with a Digi ConnectCore SOM and removes the complexity of mapping required interfaces to the SOM pinout. It helps with setting the electrical values for interfaces to meet your exact product requirements and even provides a device tree Linux kernel configuration for your software developers. We also provide an option for customers to provide feedback to us with that feedback bubble here. So you can send us improvements for the tool, bug reports, issues, enhancements you are suggesting, and even attach files if you like to explain things a little better, and then submit to us. So we're reading all that feedback and we're considering the feedback when doing new releases to integrate new features, enhancement provided by customers. With that, thank you very much and happy designing with the ConnectCore Smart IOmux tool.